Okay, grade 8, we're now dealing with congruency, right? Specifically with triangles, but we can show how it can be any geometric 2D shape. Right, so congruent triangles are triangles that have the exact same 3 lengths and the exact same 3 angles, okay? The exact, not close, exactly the same. So we have ABC with angles X, Y, and Z. I've rotated this triangle, but it still has A, B, C, X, Y, Z. It is exactly the same. What about now? I've put it upside down, and I've kept everything upside down, but it's still A, B, and C, X, Y, and Z. It's the same triangle, right? So how do we show a triangle is equal? We have a triangle ABC with X, Y, and Z, and ABC with X, Y, and Z. Now to show that these two triangles are equal, we say, right, we have a length A, and this is exactly the same as that length A. We have a length B, and we put 2 lines to show that this is different, and that is exactly the same as length B. We have a length C, and now we're going to put 3 lines to show that this is different to those two, and then we're going to put 3 lines here to show that these two are the same. We have an angle X. We're going to just put one angle there and one angle there to show that these two are the same. For Y, we're going to put 2 angles to show that these angles are different to one another. However, these two are the exact same. And then for Z, we're going to put 3 angles and 3 angles here. This is just good practice. Okay, let's look at rotation. So we have a triangle. So we've rotated a triangle. Now we're going to have a whole section of videos in this section on how to do rotation and translation, so don't worry if you don't understand it. But what I'm basically saying is this is still a congruent triangle. Why? Because these lengths are the same, these lengths are the same, and these lengths over here are exactly the same. The angles, of course, are the same as well. I'm telling you now that these angles are the same over here. So this is still a congruent triangle. Okay, now let's look at reflection. Reflection is reflecting in the x-axis, or any axis, in fact. So we have a triangle, and you can see we've moved this point 2 across, there's 4 in total, 1 across plus 1 across, 4 across plus 4 across, and this is reflected. Again, we have a whole video on this. But essentially, these are still all the same, which means it is still a congruent triangle. The angles are also the same. Let's now look at translation. We have a triangle, and we move that triangle to the left, for example, the same amount of places. This is still a congruent triangle because all the lengths and the angles are all the same. We're going to have a look at resizing, right? So resizing, we have the triangle, and we made it bigger. But this is now not congruent. Congruent is only rotation, reflection, or translation. But resizing is not congruent. It is not a congruent triangle. What about these arrows? This is still can be congruent. It can be any shape. But as long as the shape is exactly the same lengths and size, it can be any rotation you want. So yes, it looks like we've rotated that 180 degrees and moved it around a bit. Or we've reflected it and translated it. But these are all the same over here. Those are the same over there. Those are the same over here. Just for example, this is telling you that everything here is the same. So it can be for any shape, even a squiggle. Next year, you're going to learn about side, 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 which is a proof to prove that a triangle is congruent if all the sides are the same. You're going to SAS, which is side, angle, side. This means that it's a side, angle, side. The angle has to be between the two sides, right? It can't be, if that's the angle, it can't be like that, side, side, angle, right? So that is side, angle, side. That's a proof to show that these triangles would be the same. I'm not getting too in depth on this. You're going to deal with it next year. Then for angle, side, angle, you're going to have an angle, side, angle, 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 side, angle, angle, side, right? And then lastly, angle, angle, angle is not congruent, but it is similar. So if you watch a video on similarity, you'll understand this, because these could be any size. These could be increased by a ratio of A, for example, or X, and you could have made this bigger. So these you're going to touch on more in grade 9, so don't stress too much about this. Let's have a look at some examples. What triangles here are congruent? We have the 3, 4, 5 triangle, and we have A, B, C, and D. Right, is this triangle congruent? We have the same side, the same side, the same side. Yes, it is congruent. Easy to see, it's been rotated. Oh, what about this one? 3, 4, 5. It looks like it's in a different order, but it simply has been reflected. The sides are the same. Yes, it is congruent. What about this one? We can quickly see that there's no similar side here. There's no 4 here, there's no 5 here, and there's no 3 here. For here, there's a ratio. You can see that 4 times 2 is 8, 5 times 2 is 10, 3 times 2 is 6. So this is not a congruent triangle. It's similar, but it's not congruent. And what about 2, 2.5, and 1.5? Here you can simply see we halved each of the dimensions. It is also not congruent. Both are similar. Well done, grade 8s. We've done congruency. You saw why similarity was important. Now we're going to get onto quadrilaterals and their properties.